This video, I want to look at a very simple RS flip-flop. So it has two inputs where I have switches labeled S and R for set and reset, and they connect to OR gates. And then we have some feedback mechanism, whereas the output of the upper OR gate is fed back through a NOT and then into the lower OR gate. And then the lower OR gate's output is fed back through as input through a NOT gate to the upper OR gate. So we have some outputs sort of coming back around and serving as sort of some part of the input. So that is a feedback mechanism. And this is sort of at the beginnings of a unit of memory. And so it's going to sort of, we should be able to write to it to make, we usually label of the outputs as the sort of primary. So I'll take the upper one, the one that's labeled X1 is usually labeled Q, and then the other one Q prime. And that implies that they should always be in the opposite state. One, if one's high, the other's low, and vice versa. So I'm going to start it off with S high, which is the set state. So this upper OR gate will be getting an input of 1 for sure, and then that will make its output 1. Then that 1 will be fed around and inverted so that this lower OR gate will get a low and the R is low, so its output will be low. And so we are, this S being 1, we are forcing it to be a high. And if we're forcing it to be high, that's a set. So we should be able to force a high, that's a set, force a low, that's a reset. And when we're talking about forcing, we're talking about which one's high. We're always focused on the upper one, and the lower one should just be the opposite. But there should also be a hold state where, and that's going to be where S and R are both low, and then the OR gate, which is positive, will be controlled by the feedback portion rather than the R and the S. So there we are not by our input forcing something to be high or low, but we're just relying on the feedback. We're relying on what we were before, so we will be holding. Okay. So we turn it on, and I turn it on in the set mode. So right now I am forcing X1 to be high, and so I am setting it. Then I will set S low, and now though X1 remains high, and that is because now we're working from the feedback mechanism, so that low output, which is low, gets inverted, becomes a high, and that high is being fed into the OR gate. So now that high is from history, from being remembered, and we're not forcing it. If I take the S back to high, we are still we're setting, even though it was high and seems to be remaining high because of the S input going directly to the OR. We're forcing it to be a high. So it's not a remembered high, it is a forced writing high. So you can write a 1 on top of a 1, that's allowed, but it's important to realize this is a hold. This is not a hold, this is a set. Let me take I'll go back down to, and now I'm back in the hold state, and if it's high, then the lower OR gate is getting a 1, and so now we have flipped so that now the lower OR gate is producing a 1 and the upper OR gate producing a 0. And remember, we focus on the upper one, so we have forced our primary output to be a low, so we have reset. And then if R goes low, we are now in the state where we are remembering that low state. Okay, so that's the normal functioning. If S is high, then we are setting. If R is high, then we are resetting. And if they're both low, we are remembering where we were in the past. Now, the two outputs are supposed to be in the opposite state. So one thing we don't want to do, let's do it just to for fun, I don't know. If we make them both high, if we are setting and resetting, then we are putting it into a bad state that they're both high, and we don't want that to happen here. So in an RS flip-flop, we never want to do this. Okay, now I'm going to flip one switch and then the other R, but I want to show another thing that can be unusual, and that is I'm going to stop the simulation, and I'm going to start the simulation in hold state with S and R low, and then see what happens, because you're supposed to be in a good state, and then holding that good state. But if you just turn it on and you are in the hold state, then there's the question of what am I holding? So let's see in this simulation what happens. If I turn it on in the hold state, it does this weird blinking thing. So it is, I didn't start in a good state, and all of my analysis of holding and so on relied on me being in a good state, and I'm not in a good state. So I get a very unusual behavior. Okay, that's what I wanted to show you here, a simple RS flip-flop.